Hi, today I'm going to do a presentation on the webinar summary. So this webinar was based on small cells, an essential paradigm shift for cellular network. So what is a small cell? Small cells are basically compact base stations covering smaller coverage areas, serving fewer users with smaller power. The industry also defines a small cell as everything which is not macro and is not using massive MIMO. 3GPP defines BS into three categories. The first one is microcell, which is also known as mid-range base stations. Then we have picocell, which is also known as low area base stations, and then we have wide area base stations. The small cells are better choice compared to the macro cells, given the propagation characteristics of millimeter wave. In LTE, the small cells were not just used for coverage, but also for capacity and adding additional spectrum. And now in 5G era, the network operators use densification as an important strategy to provide the seamless 5G service, not limited to coverage and capacity, but also to provide performance, especially with the millimeter and rollouts around the corner. Deployment of small cells in terms of spectrum between year 2019 to 2026. The market share for private network is around 3.5 billion and is estimated to grow at the rate of 18% until 2026. From 2020 to 2023 onwards, you see the millimeter wave small cell deployment getting increased until 2026, maybe where the FR1 and FR2 deployments will be equal. Now let's talk about disaggregated RAN or split function. Option 6 is independent radio unit design. Front haul interface of NFAPI is used to establish when DU and RU come from different vendors. And in terms of bandwidth and delay, 5G NFAPI has very low requirements. Now let's look at the architecture of small cell. Over here we have a base station unit and radio unit with transceiver and analog RF. In the baseband unit, we have L1 and L2 processing synchronization and baseband processing, which is basically providing baseband signal to radio unit and further to external antennas. Then we have the small cell weight is approximately 2 kgs to 8 kgs, and the modulation scheme in downlink is 256 quilang. In order for successful 5G evolution and achieving ultra wide bandwidth and ultra high throughput, virtualized RAN and standardized open interface is very important. Apart from that, flexible architecture is also required to meet the requirements of customer. The requirements include latency, capacity, QoS, and security such as IAM and encryption, etc.